So you are here to answer the clicker question. Tell us about the end behavior of f of x equals x to the 6th minus 60x cubed.
Well, apparently end behavior is determining what the y value will be with different x values. So the idea is that if x goes to infinity, it's going to be some really big number. And in this case, even if it was a small number, you could see what would be going on. So picture if x was, say, positive 10. Then you want to think to yourself, okay, if x is positive 10, that's 10 times 10 times 10 times 10 times 10, huge number, minus 10 times 10 times 10, that's 1,000 times 60. So somewhere around, minusing a little bit from this huge number. So what's y going to be? It's going to be positive.
So what you're saying is, since x is going to infinity, I just have to imagine sticking in a pretty big number for x. And in this case, even 10 works. I mean, that's sufficiently big.
But bigger, it'll just be more dramatic.
I could see that, sure, I could see that putting like 10 to the 6th is way bigger than 60 times 10 to the 3rd. So really, all you really have to do is pay attention to the guy with the biggest power there, right?
Yes, yes. This is our
controlling term, right?
Controlling term. That is the term.
That's just going to control what happens.
Term right there. It's the
that term,
term,
x to the 6th, is controlling.
Because it controls what's going to go on with this function.
So as I put in big numbers for x to the 6th gets really, really big. So you're saying hugely big, hugely big. So you're saying that y goes to infinity as x goes to infinity.
You couldn't count this high in your whole lifetime.
And so what happens if I now put in big negative values for x as I approach
so we really
negative
have to think
infinity?
about what's going on with our exponents here. So in the case of this x to the 6th, it's going to be a negative times 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 a negative. And a negative times a negative is a positive and a negative. And so then we see that on even exponents, this is going to net out with a positive result. So once again, we have this huge positive value. In the case of a to the 3rd exponent, then that's just going to be a negative times a negative times a negative, in which case this is always going to net out to be negative. But we're subtracting a negative, so it's really adding a positive, but who cares? We just want to focus on our controlling term, which is hugely positive.
So, like when you see these, really you just have to look at, again, the term with the biggest exponent, because when numbers get pretty big, that controls what happens. Even if the next term had been like negative a billion x to the 5th, that's pretty big.
That's an interesting thought. If it was already a billion here.
But infinity is so huge,
right,
that if I
tried
put in
10, but that was really small, and you could always go bigger and bigger and bigger to trump this term.
I see. So no matter what that second term is,
find your biggest exponent,
the biggest term controls what happens.
And you focus on, is that going to be negative or positive?
So you did the second one, so as x approaches negative infinity, y approaches positive
this is
infinity.
positive.
Oh yeah,
so
right.
y is still going in the positive
I
direction.
gotcha.
Huge positive.
Huge. I get it. Thank you, Ms. Potenza.